Right hand. Okay, no. Take it away. All right. Thank you so much for being here. Do you know how hard it is to follow Mars in a presentation? I mean, is there anything more exciting, well, than being in this new facility and hearing about Mars rover? This is very fuzzy, the audio. Not sure what's causing that, but anyway, it is so exciting to be here and to be amongst all of this science which is going on. My name is Brian Klimowski. I'm the meteorologist in charge, National Weather Service here in Flagstaff, Arizona. I've served in this capacity for 23 years. How about that? There we go. We'll see. We'll hope that takes care of the static. Anyway, super exciting to be here. Like I said, I've been served as the meteorologist in charge for 23 years at the National Weather Service here in Flagstaff. What an honor that has been. We've seen a lot of weather over the past 23 years. I've been involved with multiple large wildfires, tornado outbreaks, flash floods, you name it. We've seen it in the past 20 years, but today I'm going to be talking about something, well, rather special, rather difficult for a lot of us. That is the Dragon Bravo fire. On July 3rd, 2025, about 3:25 p.m., a single lightning strike set into motion what was to become one of the largest wildfires in Arizona history. Over the subsequent weeks that followed, the Dragon Bravo fire grew explosively, fueled by record dry forests and an atmosphere that, quite frankly, was just primed for fire. It was going to happen. What we're going to talk about today is we're going to talk about that story. We're going to go into some of the people behind that story and a lot of the science that kind of drove this fire to its extreme behavior. Are you ready to get started? Yes. All right, let's do this. All right. Can we do something about this static? I guess we're going to live with it for now. All right. So the story began with one lightning strike on July 3rd, 2025. It's a part of this little handful of lightning strikes that occurred on a very normal early monsoon day. Nothing special about the day, just random convection across the area. We had 6,500 lightning strokes that day. That means individual electrical discharges, which accounted for about 2,000 to 3,000 lightning bolts, as they might appear visually. A very average day. What we've mapped here is all the lightning on that day. That's a very average day. We see a lot of lightning in northern Arizona. If this is a very average day, and our monsoon typically lasts about 8 weeks or so. Anyway, this is what the radar reflectivity looked like on the day that the Dragon Bravo fire began. Just very low reflectivity, scattered showers. Some of these were very electrical, some, as in this little storm here, not that electrical at all. Sent out a handful of lightning bolts. That was it. That's what started our fire and started our story. But this was early in the monsoon, which means very special conditions were present. Forest fuels are dry. We all know what June is typically like here, correct? It's hot, dry, breezy. It's our fire season. Widespread monsoon precipitation had not occurred yet. Like I just said, temperatures are hot, days are very long early in July, and lightning strikes from thunderstorms start fires. Many of them are put out by subsequent rain. Many of them don't take hold because it's already pretty moist in the soils. Unfortunately, some of them do take hold. The Lightning Bravo fire was discovered or first detected the next day on July 4th in the afternoon. What it became was, well, quite a monster. This was actually filmed by the Incident Management Team 2, I think on August 29th. And we saw some extreme pyrocumulus forming above the firehead as it was advancing very rapidly to the northeast. Now, what is a pyrocumulus? We kind of throw that term around, and it's pretty popular right now, but what it is it is an actual cloud which is being formed from the heat generated by the fire as it thrusts very rapid updrafts into the atmosphere, cooling and condensing into water droplets into a cloud. Now, why are pyrocumulus clouds significant in wildfires, and why are they so dangerous? They're dangerous because a pyrocumulus cloud is basically a thunderstorm, or it can be a thunderstorm above a fire. And what do we know about thunderstorms? They can cause downdrafts, strong erratic winds. They're associated with very strong updrafts, so it helps encourage fire behavior, which can become very extreme. Within those updrafts, you can get some of the burn material, the ash, sticks, things that are burning, lofted very high into the atmosphere, and then carried by the wind far in front of the burning front of the fire, causing long-range spotting. So pyrocumulus, you don't want to see. We had some very aggressive pyrocumulus on this fire. And let's move on. Anything else? All right. The Dragon Bravo ended up being the 7th largest wildfire in Arizona history. As of this morning, it wasn't officially 100% contained yet. It's been hanging out at 94% containment for a week or two at 145,504 acres. Of course, most noteworthy, about 106 structures were severely damaged or destroyed by the fire, and a lot of structural impacts as well to the North Rim and the North Rim area. Now, of course, we live in an area of frequent wildfire. You just have to look out your window at the mountains to see evidence of wildfire. Is that right? We can name 3 right off the top of our heads, can't we? Schultz Fire, Pipeline, and Museum, right? All in the past 15 years, all in San Francisco peaks. But there's been multiple fires across northern Arizona, of course, over the past 10, 15 years, and throughout our history. Our forest is, in a sense, made to burn. Ponderosa pine forests have this kind of symbiotic relationship with fire, with elevated crowns that typically don't burn, with low-intensity ground fires. Thick bark, it's actually well adapted to wildfire, especially frequent low-intensity fires. But the Dragon Bravo fire was anything but that. So as we move through the talk, you'll be good to have in your back pocket the ingredients for fire behavior, those components that come together that can feed very active fire behavior. Of course, one of the first ones is weather. Of course, there's weather which is conducive to burning and weather which is not conducive to burning. When you think of wildfire weather, you think of hot, you think of dry, you think of windy. Okay, these are features of the weather that will promote rapid fire growth. Wet, cold, and calm basically can put a fire out, or at least make sure that it never gets started. The other component is fuel. What is burning? Okay, very important component, because if you have a lightning strike or if you try to manually start a fire with wet fuel or wet timber, it's just not going to burn, is it? It's just going to smolder and nothing's going to happen. Dry fuels are the key, is the tinderbox for a wildfire and can promote its growth. And what we saw in the Dragon Bravo fire were fuels that started out in a relatively normal state in early July. Not that different from normal, but the lack of the monsoon, the heat, and the persistent, strong, dry winds we had very rapidly dried the fuels to an extreme state and eventually to record high levels across the North Kaibab Forest. Topography also plays a large part in fire activity. If you have the wind blowing up a steep slope and a forest that's continuous up that slope, fire will rapidly accelerate up that slope because heat rises, and it just feeds that fire as it rises higher and higher across the slope. Flat surfaces don't burn necessarily as fast unless they're fueled by strong wind. Okay? Downsloping can have other interesting effects. If you have a fire front that might interact with a very steep downhill aspect, you can have trees that burn up on top, fall down, and you have burning logs that then roll down the slope, ignite fires that burn back up the slope. An extremely dangerous situation, extremely dangerous. The fourth part of this is a trigger. You need a trigger to start a fire. You need a match. You need something. In our case, it was lightning. Statistically, lightning starts about 15% of the total number of wildfires. Okay, 15%. The other 85%, human caused. Okay, it's not the same ratio if you look at total acres burned. Okay, if you look at total acres burned, lightning starts to count for a greater proportion than human caused fires, because many human caused fires are in areas, well, where people are, and you have an opportunity to put them out quick. All right, so let's talk about fire progression, okay? This is a great image that was created that shows the progression of the fire from the lightning start right here as it progressed through the 145,000 acres. And let me walk you through essentially what you're seeing. Very roughly, in blue is the first week of the fire, where it was initiated here, moved to the east, and then to the south toward the North Rim structures. The second week is basically in green as it moved up to the north and east, came across the Forest Service boundary where they had a very solid line set, and it eked down here into the desert just a little bit too. So second week basically in green. The third week was the very rapid and extreme burning that happened in the third week of the event. That's everything in yellow there. Fourth week basically in red. This fire progression map stops on August 9th. That's when the bulk of the area was burned. What we're going to look at today is basically that first week and the third week that caused the extensive damage to the North Rim, and it caused over 82,000 acres to burn in just 4.5 days, late in July. Let's get started. But first, let's talk about fire intensity and burn intensity. Very important to talk about because burn intensity kind of governs the flood response we're going to see. We use some really cool satellite imagery to take a first crack at what the burn intensity is. And what you're looking at here is everywhere in red in this satellite image was burned, okay? Where it's the brightest red, most of the foliage, or the foliage is burned more completely or more intently. Where it's more black, less so, and where it's still green, there was barely any burning at all. So the way we determine soil burn intensity is we first give it a satellite estimate, and then we send what's called a BEAR team in. This is the Burn Area Emergency Response Team that goes in as soon as they can after the fire has cooled down so they can evaluate and verify what the burn intensity is, okay? We just can't take what the satellite gives us on a whole because there's a lot of variables that goes into calculating burn intensity. And since we're on the topic, let's just talk about burn intensity a little bit and soil burn intensity. It's evaluated on a number of factors, but the four main ones is how much of the ground cover is remaining. That is, how many pine needles, small sticks, or pine cones, duff might still be remaining on the surface. That's one. If you see a lot, low burn severity. In moderate burn severity, you'll see maybe 50 to 60% of all of the surface material is burned off into ash. Okay, there is not much remaining, but it is still there. Okay, you can see that the soil structure has started to diminish with moderate burn severity, and water is slightly repellent, like you pour water on it and it half soaks in and half kind of runs off. High burn intensity is when there is nothing left on the surface except ash. There's little, if anything, left on the trees except the main trunks. And water is extremely repellent. You pour it on, it just runs right off. Hence, why flash floods are such a threat after a wildfire burn, as we're well aware with our local fires. So here's just some examples. These are not from the Dragon Bravo. These are from other fires, actually in a manual on how to evaluate burn intensity. But low burn intensity, showing a lot of materials still exists. For medium intensity, you still have some structure to the trees and branches. And then high intensity burn, you're just looking at toothpicks. Okay? So the next image you're going to see will be the official burn intensity map from the Dragon Bravo fire. And here's what we have. We have very low or low burn severity at about 72% of the area. Moderate burn severity in yellow at 26%, high burn severity at 2%. Now understand the distinction here. This is soil burn intensity, not percent of trees burned, okay? Very different here. But it shows you, and it gives us as meteorologists an indication of which areas might be most prone to flash flooding, which drainages we'll have to be most sensitive to. And it kind of provides a map of how intensely the fire burned. You'll notice that where the fire burned most quickly and most intently, especially up here between July 27th and the 30th, was high intensity burn mixed in with moderate intensity. Well, we saw that pyrocumulus. This was the area that was burning underneath that. Now, I'm a curious guy, and I always want to compare things. I guess that's what scientists do. So I looked at the burn intensity percentages for a couple other fires I think we're all familiar with, or might be. I'm comparing it here to the Rodeo Chetiskyi fire and the pipeline fire. And you'll see that the percentages of high burn intensity, moderate burn intensity, low, and very low are actually among the same order, okay? The Dragon Bravo fire is in blue, Rodeo Chetiskyi in green, and pipeline fire is in yellow. Now there is a big standout fire, and it's a fire which leveraged topography in its burn intensity a lot. Know which fire that might be? Schultz. The burn intensity on the Schultz fire was 40% high, soil burn intensity. And you want to know why we had such a massive flood response on the east side of Flagstaff after the Schultz fire? There it is. We had a very thick forest that hadn't burned for at least a century or been logged for a century, high density, burning up the very steep slopes of the San Francisco peaks. Was anybody here during the Schultz fire? Do you remember that Sunday morning and turning north and seeing that huge plume? That's how gut-wrenching that was. That was quite an event. All right, so let's talk about the first of these 2-week periods we're going to look at closely. The first one here is the days from July 11th through 13th. Remember, the fire started on July 3rd, first detected on July 4th. By July 9th, it was about 59 acres, but things changed very rapidly as the weather changed very rapidly. We had a little bit of moisture on July 3rd or July 2nd and 3rd. That's where that lightning strike came from. Then things dried out significantly and several weather factors came into play. Here's the fire perimeter on July 9th, 59 acres. By July 11th, 941 acres. Look at the next day, July 12th, 3,471 acres. And July 13th, 4,609. Most of the damage on the North Rim was late, very late on July 12th. Okay. We have here. What we have here is something very interesting. We have the, sorry about that. See if I can do this right. What you're going to see is 3 days of the Dragon Bravo fire on July 11th, 12th, and 13th. Okay, 3 days. You're going to see a smoke plume start, get excited, then it'll go really low again, come back, go low again, and come back. 3 days of the Dragon Bravo fire in satellite. Let's see if I can do this one more time. Okay, so what we see here is the first conflagration on the 11th. On the 12th, you see a wind shift. Things are coming from the south, from the north to the south. Same thing on the 13th. We're going to look at that again. Okay, you'll see the first day, which is July 11th, the fire starts out relatively calm and then blows up significantly on the 11th. On the 12th, you'll notice the smoke plume is moving to the south from northerly winds. We had a wind shift. Same thing on the 13th. Okay, so this is the 11th, and it blows up. 12th, winds coming out of the north. 13th, winds coming out of the north. But you'll notice, see, the Dragon Bravo is right here. There's another big fire out there, isn't there? Which one was that? White Sage. That's right, that was the White Sage fire. And it blew up during these initial days as well. Actually, when the Dragon Bravo grew 4,000 acres, by July 13th, the White Sage fire grew 40,000 acres. Okay, very volatile situation out there. Okay, let's get past this. So, antecedent conditions, just very briefly. As we know, last winter was very light up on the North Kaibab, less than 50% of the snowfall of normal, very warm conditions in May, June. In July, helped to dry things out. June actually started out real wet, as you can remember. Pretty darn wet. Actually, the North Rim, some stations had well over average precipitation in early June. But by early July, fuels were getting critically dry. The precipitation turned off on July 4th, and things dried out very quick. And you know what is one of the stronger points of this presentation is the monsoon never did really kick in to put out this fire as it should have, but it did not. So let's look at some charts. As a scientist, I love charts. You know, this is kind of a blinding array of lines, so just focus on two, if you may. One is the black line in each one, and maybe the gray line, which lies underneath. On the left, we have what's called the burning index. It's a scientific parameter which basically says how intense could the fire be? How intense could it be? On the right is the vapor pressure deficit. Basically, it's the atmospheric drying power. It's how dry the atmosphere is and how the winds and dryness might drive further drying of the ground. And what we see here is in the how intense the fires could be, starting out in April, May, and into June, guess what? It's just pretty normal. You know, the fuels are curing pretty normally. We had the big wet June here, which dropped the potential for fire ignitions and intense fire behavior very low. Then it increased back up to normal, but to a critical level, which is typical of late June, early July. Then we had the weak storms on July 3rd and 4th, which caused the lightning strike that started the fire, and then things dried out very rapidly and actually got well above normal, which is normally decreasing at this time. On the vapor pressure deficit, or how dry is the atmosphere and how might it drive drying of the fuels, you'll see that after that rainfall in in July, it skyrocketed. We had a very dry air mass in place with extraordinary drying of the fuels right after that lightning strike. Okay, let's look at a couple more common parameters like temperature. This is the temperature of the Bright Angel Station, which was not far from the North Rim. And the lightning ignited the fire here. This is the high temperatures on July 4th, low temperatures, July 5th, 6th, 7th. See how this is progressing. This is an average high temperature, which is around 78 at this time. You can see that it got very hot very soon after lightning started the fire. And then even hotter, got up to almost 90 degrees at 8,100 feet. Okay, 8,100 feet. The rapid growth from late on July 10th through the 13th happened in this period. Some very important factors here. Look at the low temperatures at night and what's not happening. It's not cooling off. Okay, we have enough winds in place and actually some downsloping at this time, which is keeping the low temperatures near 70 degrees. Is that going to inhibit fire behavior? No, that fire is going to run day and night because we're not cooling off significantly. Actually, our low temperatures on July 11th and 12th are near the average high temperatures for that date. Phenomenal. Let's look at relative humidity. When the storms initiated the fire here, pretty average signature that we see with the relative humidities falling and rising between, let's say, 20-30% to 60-70%. Some dry westerly flow begins as the monsoon circulation is pushed to our east, and the relative humidity does not go above 30% and falls below 20% and even 10% in some locations as we get into this period of rapid fire growth late on July 10th through July 13th. These are exceptionally low relative humidity levels, exceptionally low. We're talking relative humidities down to 5% with temperatures near 90 degrees. We had near record highs at this time and extreme heat warnings going on in the Grand Canyon for this heat. The dryness was exceptional. So what was happening? Fuels were drying extraordinarily fast, just as this fire was taking root. Okay, one other factor that goes into this is we had a dry trough pass through, basically a front from the northwest. It swept through on July 11th, and by late on July 12th, the wind direction had changed to a more northerly, northwesterly direction. Unfortunately, that's a very critical factor to the fire growth at this time. Because as we know, it took the fire front from a location that was north of a lot of the infrastructure on the North Rim and just dialed it right in to the North Rim late on the 12th. A lot of complicating factors on July 12th, and I won't get into that at this time, but we'll talk about the meteorology and the rapid fire growth from the 10th through the 13th that consumed the North Rim. We had winds shifting to the northwest, measured to about 20 miles an hour, but observed boots on the ground about 40 miles an hour. Understand we're dealing with very complex topography, and northerly winds on the North Rim are actually downsloping and funneling through some of the North Rim canyons there, leading to erratic winds and extreme fire behavior. We had extremely low relative humidities, especially from July 10th on. Fuels dried rapidly. We saw that in the burning index. That's a reflection of fuel dryness. And the topography, the steep canyon terrain accelerated the upslope spread and erratic, unpredictable fire movement. And wind amplification and funneling was likely going on at that time in this area of very complex topography. The next week, okay, after July 12th and 13th, we had a return of some, pretty, I'll just say average weather for the monsoon. We didn't have any rain, but we didn't really have a dramatic shift of the winds. We had a return to our normal kind of southwesterly flow. But you get toward the third week in July and things changed again. We had a trough, that is low pressure, set up over the west coast, okay? That pushed the monsoon moisture all to the east and kept us under this persistent, dry southwest flow. It was irritating as heck to us meteorologists because we love to see, weather. We love to see our monsoon that we love and that precipitation and the moisture. But that trough was pushing all the moisture to our east. New Mexico was very wet this year, but we were very dry. And those southwesterly winds that came up pushed the fire through 82,000 acres in about 4.5 days. And let's just briefly look at some of the weather parameters associated with that. But first, we're going to look at some satellite imagery, but this is very special satellite imagery. What you're about to see is the reflection of the burning front of the fire in satellite imagery. Okay, you'll see it over about 5 days, advancing through this period from like July 24th through July 31st, when it expanded about 80,000 acres. This is one of the tools that we use to identify where the hot spots are in a fire. When especially we can't have overflights, maybe perhaps because the fire is burning too hot. But it gives us kind of a continual measure of the fire intensity and the burning front. So let me show you that real quick. So you see on July 24th, the burning front was here, then it just exploded to the north over those couple days. And you'll see how fires burn on the edges and push out. Let's look at that one more time. Fascinating new imagery that we get, but you can see that in about a 3-day period, boom, 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 it just races toward the north as it's fueled by these persistent southwest winds and southerly winds. An air mass that actually reaches record dry levels, and the fuels that continue to dry even more. Some amazing statistics about the Dragon Bravo fire at this time, which we'll look at very briefly. Okay, first one is the precipitable water in the atmosphere. Now that's a fancy term for saying if we took a column of air above our heads and squeezed out all the moisture, how much would you have? Okay, our balloon launches or radiosondes measure that twice a day. So I went ahead and plotted that on this graph from basically July 1st all the way through the end of August. I put what would be the normal values here in blue and shaded the two areas of explosive growth that between July 11th and 13th and July 24th through August 1st here. And you'll notice a couple of things. Absolutely extraordinarily low values of precipitable water in the atmosphere as measured from our weather balloon. And in this period, it is absolutely phenomenal. These values here are actually record dries. We've never had values that low during this time of year in the middle of the monsoon when it should be wet and moist. It should be wet and moist, but it's as dry as it's ever been for that time of year. An extraordinarily plot, and these values tell a lot of the story. Let's look at some more of the parameters. This is the mean surface mixing ratio, or the moisture content at the south rim of the canyon, a place we can easily measure it. And you'll see that the highest and lowest values are outlined in gray, the median is in blue, and you'll see in this period in late July, when the fire grew 82,000 acres, the moisture content was at its record lowest at one point, which was on the south rim of the Grand Canyon. So the north rim was probably very similar. Absolutely extraordinary. That trough over the west coast looked like this. If you like monsoon moisture, you do not like this weather pattern because it feeds dry air off the cool Pacific over northern Arizona and keeps our kind of monsoon circulation pushed well to the east. We saw this on multiple days in late July and early August. It resulted in strong winds, red flag warning criteria, which is, by the way, you've probably heard the term red flag warning when paired with fire weather. For us in northern Arizona, it's for when we can forecast conditions of winds in excess, sustained winds in excess of 20 miles an hour, wind gusts over 35 miles an hour, relative humidities below 15%, and high fire danger. Basically, when all those come together, we can issue a red flag warning. And we had local red flag warning conditions on several days during this period. Another interesting graph. What we're looking at here is the average high temperatures through about a 6-week period from the 1st of July through 20th of August, and then summarizing it in a single bar. So in 2025, the average high temperature through that period was, over 87 degrees through that period. What I've done is I've run this back through time and looked at similar periods all the way back from 1970 all the way through 2020. This is also at the South Rim station that I used for the previous one. And you'll see that that period where the fire grew so much, it was the 4th hottest on record through that period. And you'll probably see a trend in that graph as well, going up. Yeah, things are getting warmer. No mystery there. Burning index, vapor pressure deficit for this latter part of the fire growth was record. The burning index got to record high levels. It's never been this high in late July and early August. It reached, over the 95th percentile, which is the potential for extreme fire behavior. Fuel's extremely dry. It's exactly what we saw. The vapor pressure deficit showed the same trends. But a remarkable statistic is that from July 5th through August 15th, the rainfall at Bright Angel is normally about 3 inches. Okay, this is from the day after the fire was detected, and for another 6 weeks, we average about 3 inches of rain. How much fell at this Bright Angel station? Less than 1/4 of an inch. We only had 2 days of rain through that entire period. Now, some parts of the fire saw a little bit more, 1/2 inch, maybe just over 3/4, but still far from the average of 3 inches. The lack of the monsoon was a critical factor in the growth of this fire. Okay, so the rapid growth from July 25 through August 1st, record dry air mass. We showed that. Persistent strong winds, local red flag conditions on many days, much above normal high temperatures. Instability led to massive pyrocumulus formations. We had long distance spotting, lack of rainfall promoted long period of favorable wildfires spread, and fuels reached critical record dry values. All the ingredients were there, folks, for rapid fire growth. This is a fire that at this point would be impossible to manage. You can't get in front of a fire like this. It has to be managed very strategically, very safely for the just lives that are all out there fighting the fire. Now let's talk about the role of the National Weather Service. What do we do to support firefighting operations or those out in the field? Of course, we issue forecasts. We issue specific fire weather forecasts for every zone in northern Arizona, at least twice a day. We issue spot forecasts. These are forecasts requested from us for specific locations, most often for fires. They might be prescribed burns, they might be managed burns, they might be wildfires, which haven't grown too much yet. We also issue red flag warnings when those times that we see coming up that we might have high winds, low relative humidities for a long period of time where there's high fire danger. We also do a lot of what we call decision support services. That's on-site deployment with core partners. It means we spend at least 2 weeks a year on-site at the Prescott Fire Dispatch, supporting those folks in response to and to fill some communication gaps that were discovered during the Yarnell incident way back in 2011. We provide specific briefings and forecasts for high impact fire weather as requested, or sometimes just as needed. We are a part of the team and a part of the conversation for post-fire hazards and flood assessment. Okay, the flash flood warnings that are issued come from our office, so we need to know what are those thresholds we might use for flash flood warnings and what areas might be flooded. We aid in the development of these flood thresholds, and we provide incident meteorologists to serve on-site at the wildfire. What you might know or might not know is that in most large wildfires, there is a meteorologist who's dedicated and on the front lines with all the fire managers on that fire. They're in camp. They're often sleeping in tents. They work 16 hours a day. They provide briefings to all the fire personnel. Those are called incident meteorologists. We've had a number of incident meteorologists in the National Weather Service office here in Flagstaff. Right now, we currently have only one, and that's Robert Rickey. Now, the post-Bravo flood risk. What's very true is often the post-wildfire floods are often more deadly and damaging than the fire itself, okay? And we have a lot of resources at risk right now in the Grand Canyon, especially those along Bright Angel Creek. The Bright Angel drainage was severely burned, especially high up in the drainage. And the flow down Bright Angel Creek and Phantom Creek that comes in just above Phantom Ranch is expected to be much, much, much above normal for any significant rainfall that we get. The response is going to be very high. There are assets at risk, everything from the water pipeline down there to Phantom Ranch itself that could be threatened in the case of a major flash flood. So we're working very closely with the Park Service, the USGS, and other agencies to set up warning strategies for the Bright Angel Creek area. But there's other river miles that are impacted by drainages that drain out of the Dragon Bravo scar. North Canyon and South Canyon river miles 17 and 21 could be powerfully impacted because a lot of the area that was burned up here drains down these two drainages. And we've already seen some flooding in these drainages. This was from a USGS survey of the North Canyon drainage, showing some of the ash very far, we're talking miles downstream from the fire itself, working its way down to the Colorado River. And on the Grand Canyon Expedition's Facebook page, they showed the Colorado River turning black from ash, okay? They came out of North Canyon, likely from the 5th or 6th of September event, I should say 4th or 5th. So things are happening. We haven't had a truly massive rainfall event over this burn scar yet, but we will, okay? It's going to happen. We need to prepare for it. So on-site meteorologists. We talked a little bit about IMETs and what they do, but what I want you to do is just listen to Rob Rickey himself. The other day I chatted with Rob, asked him a couple questions. He spent 16, 17 days up on the Dragon Bravo from the 27th through August 11th during this massive growth period. Rob was the IMET on site supporting those managing the fire. Let me start a little video here.
Okay, Rob. So tell us, what does the National Weather Service IMET do when supporting a large wildfire?
So really, the main task of an IMET on a large wildfire is really to keep the firefighters and the public safe. And so we do that through two main ways. We make weather forecasts that are specifically targeted for the weather fire itself, so very dialed into the fire to give folks basically a heads up if there's any unexpected weather on the horizon or any hazardous types of weather. And then the other big responsibility is really just briefing those weather forecasts to make sure that people understand what's coming in. So I'll spend about half my day working on a weather forecast, and the other half of the day is basically briefing. So briefing firefighters, the crews before they go out for the day, briefing the decision makers for planning so they can design tactics to contain the fire, days or even maybe a week in advance. And then also members of the public and various stakeholders. So there'll be people impacted by the fire. You could think of like a rancher. You could think of utility companies, and so I'll be giving them briefings to update them on the status of the fire as well for their planning, and so that they can make adjustments in order to kind of mitigate the impacts that the fire is having on them.
And I asked Rob one other question.
And Rob, to wrap it up, what would you say might be one of the most memorable aspects of this fire?
I would say the most memorable aspect was really like the fire activity. We weren't necessarily dealing with really super windy days, although we did deal with multiple days of gusty winds, which is somewhat unusual during the monsoon season. But we were so dry that the fire activity would pick up early in the morning, would put up huge plumes with very, very extreme fire behavior, and that fire would continue to burn through the evening and even most of the overnight hours, because we were just dealing with such dry conditions that really the humidities never really came up enough to subdue that fire activity. So it was really day after day after day of very extreme fire behavior.
And that's what it felt like, didn't it? As we looked at the news, as we followed this story, it just seemed never ending, that the fire continued. It was so hard to manage, burning in such extreme conditions. So, you could almost summarize it by saying the Dragon Bravo fire was initiated in the worst place, at the worst time, followed by the worst possible conditions. Okay? A lot of fires start early in the monsoon. A lot of fires are put out very quickly by rains that follow. Not the Dragon Bravo. We know that the fuels were extremely dry. The weather was anything but favorable. The weather was really the major driving fire, or the major driving force, along with the very dry fuels. Now, of course, the Weather Service is going to continue to work hand in hand with all the fire weather partners and other agencies to continue support any mitigation efforts, strategies for flood warnings. These conversations are continuing and will probably continue for the next couple years. So at this point, I'll take any questions you might have. Thank you.